to this channel. This is the first video of topic 1 matter, where in this video we will have 3 subtopics to cover. The first one is your topic 1.1 atoms and molecule. The second will be your 1.2 mole concepts. The third one will be your 1.3 stoichiometry. And in this topic, most of the time we will be doing a lot of calculation, so make sure you have your calculator ready. Let's start with the topic 1.1 atoms and molecule. For this first part of video, it will be more on definition and understanding what it actually means by all the important terms in chemistry. We are going to look into the definition of few keywords, and they are metal, atom, what is actually element, molecule, compound, mixture, and ion. So we are going to look into all this definition. Alright? Don't worry, other than the definition, examples will be coming along. So your topic 1 is matter. So the first question is definitely what is actually matter stand for. Matter is anything in this world that takes up space. Alright, means that it has volume and also it has mass. So for example, pen. Pen is definitely a matter because it will take up space, it will have mass. For example, bottles, your water bottles is also taking up space and also having mass. Other than that, like chemistry, your beaker, any type of container is actually taking up space and have mass. Your air, your oxygen gas, your carbon dioxide gas, they are also having mass. So they will also be taking up the space in your atmosphere. And that's why all this air is also a matter. Then the question will be, what would be non-matter? So what is actually not taking up space and also not having mass? Very simple example, feeling. You're feeling sad, you're feeling happy. All that doesn't take up space and it doesn't have a mass. You cannot measure what is the mass of your happiness. So feeling, all sort of feeling is an example of non-metal because it doesn't take up the space and also it doesn't have a mass. So that is the difference between matter and also non-matter. Bear that in mind, matter is everything that takes up the space and also having mass. That will be your matter. Matter can be separated into 2 different categories, which are substance and also mixture. And let's look at substance first. Substance can again separated into element and compound. While in element can be separated into atoms and molecule. So by that in mind, elements is everything that you have in your periodic table. Alright, so you have your periodic table over here. So everything that you have on the periodic table is what is your element. While your compound can separate it into your ions and molecule. Alright, so we are going to look at the examples and definition of each and every words that we have on the screen. Well, last but not least, mixture. Mixture is quite simple and straightforward. Mixture can be separated into homogeneous and also heterogeneous. So we will also look into the homogeneous and the heterogeneous mixture. And we will start off by looking into the definition of atoms, molecule, and also ions. Before we categorize the atom, molecules, and ion are under element or compound. Okay? So let's start off with atom. What is actually atom? Atom is the smallest unit of a matter that made up of 3 subatomic particles. So what are the subatomic particles? Your proton, your neutron, and your electron. That are 3 subatomic particles. Okay? So atom is actually the smallest thing that you have in chemistry. It's the most basic thing that you have. And inside an atom, you can only have proton, neutron, and electron. It's actually this thing that you draw. If you remember, that is your nucleus. So inside your nucleus is where you have your proton and also you have your neutron. Okay? And then around the nucleus, you have your electron. Okay? If you remember, your electron will be circular around the nucleus. So this is the basic atom. One atom, you have your proton and neutron in the nucleus. And then around the nucleus, you will have all the electrons circular around the nucleus. That is actually atom. So let's say if I have the atom of carbon. How should an atom of carbon look like? You have your nucleus, And we know that for carbon, in the nucleus, you will have 6 proton and also you will have 6 neutron. And around the nucleus, you will have 6 electron. So you know that you have 2 in the first shell, and then you have 4 in the second shell. So this is 1 atom carbon. Okay? So 1 carbon will look like this, the smallest, tiniest thing in chemistry. Of course, the smallest atom that we have is hydrogen. Okay? Because hydrogen only have 1 electron. Simple? Easy. Next, what is actually molecule? Alright, molecule is definitely bigger than the atom. Molecule consists of 2 or more, so it can be 2, 3, 4, 5 atoms of the same atom or the different atom chemically bonded together. So chemically bonded together means they must have a bond between them or they must undergo certain reaction to be binded together. Okay, that is the keyword, chemically bonded together. Another keyword over here is the same atom and also different atom. For example, if they are the same atom, the example is oxygen gas where you have O2 gas. So when they are the same atom means that you have 2 oxygen atom combined to become 1 oxygen gas molecule. Alright, 1O combined to become 1 O2. That is your oxygen gas produced. Another example could be your chlorine gas. Everybody knows that when it's a gas, it's a Cl2. So when it's a Cl2 means you have 1 chlorine atom combined with another chlorine atom to produce 1 chlorine gas molecule. That is when the molecule is produced from the same atom. You can see that it's the same atom combined together. What happens when you have a different atom? Example, carbon dioxide gas. You know that carbon dioxide gas is a CO2. CO2 means you have 1 carbon combined with 2 oxygen atom to produce 1 carbon dioxide gas. So you can see you have different atom. You have carbon atom, you have oxygen atom combined to become 1 carbon dioxide gas molecule. Different atom. Okay? Your methane gas over here, simple, is a CH4. So we have 2 different atoms from different element, which is your carbon plus 4 hydrogen atom. So 1 carbon atom combined with 4 hydrogen atom will give you 1 CH4 molecule. So can you differentiate what type of molecule will be produced when you combine the same element or different element together? Make sure they are chemically bonded together. Alright? Next, what is ion? Ion is simple. It's a negatively charged. It can be negative or it can be positively charged particles or compound that result from gain or loss of 1 or more electron. Okay, so bear that in mind, you can be a negative charge, you can be a positive charge by only gaining or losing electrons. Bear that in mind, the only things that you can lose is actually electron. Proton doesn't change because proton is in the nucleus. So the only thing that can be added up or removed is electron. So when you gain electron, okay, you will actually form a negative charge. A negative charge over here called anion. Okay, the example of anion that you will be formed is like your O2 minus, your Cl minus. That is all sort of anion that you can form. It becomes an O2 minus because you accept 2 electron, Cl minus because you accept 1 electron. So 1 electron will give you 1 negative charge. When you accept 3 electron, then it will be 3 minus. Okay? Next, Loss of electron means losing electron will give you cation. Cation is your positive charge. Vice versa as your anion, losing one electron will become positive one, like your Na positive. Become Na positive because your sodium lost one electron. It can be 2 positive when it lost 2 electron. Your magnesium loses 2 electron. That's why it becomes Mg2+. That is your ion. Cation, anion. Okay, positive ion, negative ion. Simple. Next, let's move into substance. What is actually substance? It's a matter which has specific composition and specific properties. And we know that substance can be differentiated into element and also compound. Element, for example, sodium, your Na. Oxygen gas, your O2. Look at that, there is no mixture, just one element. One element. You cannot mix them up, okay? Just one single element. If you are using Na, then just Na. Oxygen gas, then just oxygen. Or chlorine, just Cl2. Alright? Magnesium, just one element, okay? Same element. Compound means that you combine different elements. Methane, you have your carbon and hydrogen combined together. Carbon dioxide, you have your carbon and oxygen combined together. So your compound will be formed when you have more than one element. Okay, so when you combine 2 or more elements. Okay, so in the methane, you have carbon and hydrogen. In the carbon dioxide, you have your carbon and oxygen. So substance is a metal that you have a specific composition and specific property. You know that CH4 must be holding 1 carbon, 4 hydrogen. So that is the specific composition and properties. Carbon dioxide, 1 carbon, 2 oxygen. That is the specific composition and specific properties. Okay. Next, what is actually element? Simple. Everything that on the periodic table. Every single box in the periodic table that you have is actually an element. So it's a substance that made up of only one type of atom. Okay, you must only contain one type of atom. So I just want to remind you again, if you remember your periodic table, alright, every single boxes that you have in your periodic table is an element. Okay, so simple. And we know that element can be differentiated into atoms and also molecule. And we talked about atom and molecule just now. And we know that atom is the simplest and the smallest unit that you have in chemistry that contain only proton, electron, and neutron. Okay, so the example of atom is like your sodium, where you only have the simplest thing, just one, Na. Iron, Fe, just one. Neon, alright, so they are just one, the simplest and the smallest unit. Okay, while molecule is when you combine them, when you combine the same type of atom. So oxygen gas, you have your O2 over here, you combine your oxygen plus with oxygen, same type. Chlorine gas, Cl2, combine Cl. Next, you have your nitrogen gas, you have your N2. Combine nitrogen atom with nitrogen atom. So element must be the same type of atom, one type of atom only. Okay, that is element. And element can be in atom, element can be in molecule, atom when you only have one thing, molecule when you have combined of the atom, but must be from the same element. Next, what is compound? Compound is a substance that composed of 2 or more elements, okay, that are chemically bind together. So substance is different than your element. Element is only just one type. Substance is 2 or more elements combined together. And we know that your compound can be separated into ions and also molecule. And the example of ion is like your OH minus. And it's a minus over here, ladies and gentlemen. Therefore, this is an anion. It's your negative charge ion. Okay? And why I say it's a compound? Because you have oxygen combined with hydrogen. So you have two different elements that combine together chemically and form OH- and N ion. Another example, you have your sulfate ion, SO4 2-. Again, similar like your OH, you have your sulfur combined with 4 oxygen. So when your sulfur combined with 4 oxygen, it's become SO4 2-, again an N ion negative charge over here. Okay, so you can see you have two elements that chemically combine together. Well, for molecule, simple, I have water which is H2O. So in the H2O, it's quite obvious that you combine two different elements which is hydrogen combined with 2 oxygen. So you form your water over here, and that is your two different elements. Last but not least, your methane, which is your CH4, and quite obvious you are having carbon plus with 4 hydrogen atom to form 1 CH4. And that is the molecules under the category of compound because you combine 2 or more elements together. Okay, simple, easy. Last but not least, let's look at what is mixture. Mixture is actually quite simple and straightforward. It's actually a group of 2 or more substances that will be physically intermingled, means they are not chemically combined. Okay, the main difference between mixture and compound is chemically bonded, if you remember. Okay, well, mixture right now is physically intermingled. So the main difference over here is the word physical. So they are not going to undergo any chemical reaction. You're only basically going to mix them up and you can easily separate them. Okay, that is actually mixture. And we have 2 types of mixture, homogeneous and also heterogeneous. The main difference in homogeneous is there will be no visible boundary and also it will form a uniform composition. So homogeneous is quite simple and straightforward when you have like salt water. So when you have salt water, the salt dissolves in the water and you cannot differentiate which one is water, which one is salt. So that is your no visible boundary, okay? But your heterogeneous, slightly different. Your heterogeneous will be vice versa of it, where you will have a visible boundary and also a not uniform composition. For example, mixing up oil and also water. So you have your water down there and then you can have your oil on top and you can see an obvious boundary. Okay, so the obvious boundary will give you a not uniform composition and that is your heterogeneous. So homogeneous, uniform composition, heterogeneous, not uniform composition. Simple. A list of homogeneous over here, where you have your air, the mixture of air in your atmosphere, you have your oxygen gas, you have your carbon dioxide gas, you have your carbon monoxide gas, but you cannot differentiate them. So I have a lot of air in here, but I cannot see which one is oxygen, which one is carbon dioxide. Coffee, you have your coffee and also water, and they are completely dissolved. So you cannot differentiate which one is coffee and which one is water. Your orange juice, bear that in mind, this orange juice is without the pulp. Okay, so just pure orange juice without any solid in that. Steel, we know that steel is actually a mixture of different metal. So steel, when you have a steel, you cannot differentiate which one is copper, which one is iron, and so on. Salt water, like I say, maple syrup, ketchup, vinegar. We know that in the ketchup, there is a mixture of a lot of different ingredients. You have salt, you have tomatoes, you have sugar, you have water, everything. But when in the form of ketchup, you cannot differentiate which one is salt, which one is sugar, and where is the tomatoes, right? Next, your heterogeneous mixture over here. You have your salt and your sand. So I have some salt, I have some sand, and mix them up. No reaction, nothing. We are not going to melt it. So you can see which one is your salt, which one is actually your sand. You have the mixture of almond and cashew nut. You buy a pack of mixed nuts and you can differentiate which one is almond, which one is cashew nut. Ice water, simple. When you have ice water, you can see the ice floating on top, you can see the water at the bottom. Oil and water, even more obvious. Cereal in the milk, you can see which one is milk, which one is cereal. You can differentiate that. You can still take out the cereal out of the milk. Your garden salad, you have all the gravy, your sauce, your all type of veggies in the garden salad. Chocolate chip cookies, you can see where is the chocolate chips, where is your nuts and everything in the cookies. Obviously, chicken curries, you have your gravy, milk, chicken, oil and everything. So you can see all the different boundary. Okay, so that is the last thing for this video. Very simple basic video on how to differentiate all the important terms in chemistry that you'll be using throughout the semester. I hope this video helps you a bit to understand all the terms. If you have any question about all the terms, drop the question in the comment below and I'll get back to you as soon as I can. I'll see you in the next video and thank you for watching.